Hello, welcome back to another video lecture for base math. Today we're going to be talking about slope. Now, slope is a numeric measure of steepness of a line. It is often denoted as the letter m. So here we say that slope, or m, is known as rise over run. And that's kind of how we figure it out. So if you were to have a line, you'd kind of look at it, and our run is how far it goes in the x, and our rise is how far it changes in the y. Now this change in y could be up or down, depending on the graph. So let's work out a short little example, just to kind of see. So suppose we have a graph, and our line passes through a few points. Now, if we look closely, we can actually find 2 points where this passes through. Passes through here, and it passes through a point right here. Now, if we use the scale on the graph, this point here would be 2, 1, and this point here is 1, 2, 3, 4, 5, negative 5, comma, 1, 2, 3, negative 3. So those are our 2 points that we're going to use to find the slope of this line. So if we look here, we can kind of connect make little trace a triangle here, connect the line, the dots that way. And we have a rise of 1, 2, 3, 4, 5. So rise equals 5. And our run is going to be 1, 2, 3, 4, 5, 6, 7. So this means that slope, m, is 5 over 7. Now suppose that our line were to go down instead of up. So let's go ahead and redraw our line in a different direction. Let's take out this here. Fix our graph. So suppose that it went this way. Now, one of the points that it passes through, that's the easiest one to find, is 0, 0. So we can see that it passes through 0, 0 here. And it appears to pass through this line here as well, or this point here as well. So if we count this one's 0, 0. This one is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Negative 6. Then we connect them like so. We can see that our rise is actually here. And your run, you could put down here or up here, doesn't really matter. But our rise is negative 6, and our run is 7. So this gives us a slope, m, equal to negative 6 over 7. And it doesn't really matter if the negative's on the top or the bottom. If we were to put the negative on the bottom, that means that we're going this direction. And so if we went 7 in this direction, we would go back 7 this way, and then up 6, we still stay on the line. So whether you start here and go down and over, or you start here and you go up and then left, your rise and run ratio will remain the same. So the formula for slope, to find slope, we said is m equals And this is our rise over run. But it could also be the change in y over our change in x. This can sometimes be shorthanded as delta y over delta x. This delta means the change or the difference between. And if we were to write this another way, we would often just say that this is y2 minus y1 over x2 minus x1. So let's do a quick little example using this method. Suppose that you're given a line that passes through 2 points. So find the slope of the line passing through, let's say, -3, 4, and 2, -2. So first we start off with our labeling our points as either x1, y1, and x2, y2. So I'm going to go ahead and just say this one's x1, y1, and this one's x2 and y2. So that means that we're going to put for y1 4, for x1 -3, for y2 is going to be -2, and x2 is going to be 2. So if we plug these into our formula here, y2 minus y1 over x2 minus x1, this is going to be, once again, -2 minus 4 over, and then x2 is 2 minus -3. So this is a 2 minuses, so this turns into a 2 plus 3, which is 5. And then here we've got a -2 minus 4, so it becomes more negative because it's subtracting a positive. So this becomes -6. And we can simply just write this as negative and then 6 over 5. Both of these are correct. It's just good to know that it's safe for you to bring the negative out to the side. Now, an important thing to note is that it doesn't really matter which one you choose as your x1 or x2 and your y1 and y2 as long as they stay together. So suppose that we said that this was x1, y1, and this was x2, y2. And we plug those into the formula. So what this would give us would be 4 minus -2 over -3 minus 2. 4 minus a negative, positive minus a negative makes it more positive, so this gives us a positive 6 over, and then a negative minus a negative makes it more negative. So this would be -5, which once again comes out to be -6 over 5. So as you can see, it doesn't really matter which direction you start from or which direction that you're going in, as long as you keep the pairs together. Now let's consider if you were given a table of ordered pairs, would you be able to find the slope? So suppose that we had a table. We'll start x and y. One, -5, 2, 6, 3, 17, 4, 28. So let's suppose that this was our table. Well, we can figure out a little bit of the rise and the run here if we consider just these changes. This is a +1. This is a +1. This is a +1. So from -5 to +6, this is a change of +11. Here from 6 to 17, this is also a +11. From 17 to 28, another +11. So the rise would be 11, and the run would be 1. Now you could easily go from 1 to 3 and say, well, your run is 2, but then your rise is 22 because you're going from -5 to 17, which still simplifies to 11/1. So whichever pair of ordered pairs you pick, you'll still get the slope of 11/1, which simplifies to just 11. Now let's look at a different set, another table. Let's try, wrong color, sorry. Our X and Y, new table, -12, -9, -6, and -3. And we'll go ahead and say 12, 7, 2, -3. So if we look at these, you'll see from here to here, that's a jump of 3. Here, another jump of 3, and here, another jump of 3. From here to here, this is a jump of -3, or -5, -5, and another -5. So as you notice, each of these is the same. This -5 is the same on all the y's, the +3 is the same on all the x's, so that's how you know that your rise and your run is those things. Our rise is going to be -5, and our run is going to be +3. So our slope, m, is going to be -5/3. So, I hope that's helped you out with the basics of slope. Good luck, and have a good day.